Science fiction is full of stories about contact between Earth and civilizations beyond the stars. Today's guest is leading a multinational effort to scan the heavens for evidence of extraterrestrial intelligence. He's Dr. Andrew Siemion this week on Story in the Public Square. Hello and welcome to Story in the Public Square, where storytelling meets public affairs. I'm Jim Ludis from the Pell Center at Salve Regina University. Joining me as he does every week is my great friend and co-host G. Wayne Miller of the Providence Journal. Each week we talk about big issues with great guests, storytellers, scientists, novelists, and more to make sense of the big stories shaping the United States today. This week we're joined by Dr. Andrew Siemion, director of the SETI Research Center at Berkeley, and an astrophysicist at the University of California, Berkeley. Andrew, thank you so much for being with us.
Thank you very much for having me.
So, there's great fascination, I think, in the public mind and certainly in scientific, in science fiction literature about contact with civilizations other than our own. You're actually looking for signs of those civilizations. Tell us what SETI is.
Yeah, that's right. So SETI is an acronym. It stands for the Search for Extraterrestrial Intelligence. And in our research, we're trying to determine the prevalence of intelligent life in the universe. Is humanity alone in the universe as intelligent, technologically capable life, or perhaps is there many other examples of technologically capable life elsewhere in the universe?
And how long has SETI been around? If I remember correctly, Carl Sagan was involved in the founding.
He was, yeah. Carl Sagan was an incredibly important foundational figure, really, in SETI. There are different ways to answer that question. From one perspective, whether or not we're alone in the universe, however we define universe, is a question that humanity has asked since humanity has existed. But we usually mark the beginning of what we call the modern search for extraterrestrial intelligence. That is, the kinds of experiments that could actually succeed in detecting distant, largely electromagnetic signals, as being in 1960, when Frank Drake of Drake equation fame conducted the very first search at centimeter radio wavelengths.
So how did he conduct those early searches many years ago now? Obviously, 60 years ago, exactly. It would be crude by today's standards, but I'm guessing it was sort of revolutionary or cutting edge then. Tell us more about what he did.
Yeah, absolutely. So, certainly crude in the sense that we can now search much more of the radio spectrum at much higher sensitivity. But from a methodological perspective, the kinds of searches that Frank did in those very early years are very, very similar to what we do now. In 1960, radio astronomy, the science of using radio telescopes to analyze the universe, was really in its infancy. And the very first radio telescopes were being built all around the world. And Frank was in a fortuitous location in Greenbank, West Virginia, the home of the then recently formed National Radio Astronomy Observatory. And there was an 85-foot telescope that had just been constructed there that had a very sensitive receiver that was designed to look at neutral hydrogen in our galaxy, a signature of hydrogen that had just been discovered at radio wavelengths. And Frank developed a very sensitive receiver and a very sensitive tuning apparatus that allowed him to tune across the bandwidth of that receiver to look for a lot of electromagnetic energy at just one frequency. A carrier wave or a tone. This is something that the natural world doesn't do, and that only, as far as we know, technology can do.
Did he find anything?
Well, there are differing stories about that, and if you want the full recital of that experiment, you certainly should talk to Frank. He did detect a couple of signals, all of which ended up being attributed to what we call terrestrial radio frequency interference, examples of our own technology. Of course, we use our own technology as an example of the kinds of things that we're looking for. And today, this now is well known as really the most significant problem in radio SETI, is actually telling the difference between our own technology and a very distant, very weak technology.
So this was 1960. How was this greeted both within the scientific world and the public? I'm assuming there were news accounts of this. This was quite an extraordinary thing at the time.
Yeah, there was an extraordinary amount of interest, both on the part of the public as well as the scientific community. Just a couple of years after Frank conducted that very first search, actually a meeting was convened at the Green Bank Observatory by the National Academy of the Sciences, the most prestigious scientific body in the United States, to discuss the search for extraterrestrial intelligence and Frank's work. Frank was tasked with organizing that meeting, and it was attended by the most prominent scientists across the spectrum of science. In fact, Melvin Calvin, a chemist, attended that meeting and received word while he was at that meeting that he won the Nobel Prize for his discovery of photosynthesis. So really a who's who of science of the day. And of course, there were many articles describing Frank's search and publications like the New York Times and many others. So a huge amount of interest. It really captured the imagination of the scientific community and the public alike.
So we're 60 years later now, and we all, those of us who are of a certain age, have an appreciation of how technology has evolved in those last 60 years. Tell us, how is the work of SETI different today? And tell us, I guess even basically, I'm asking, what you're looking for a signal that would not be naturally occurring. The question I have always had about SETI is, how do you know that they're operating the same electromagnetic bandwidth that we're looking at? So those are two separate questions, but that's what's on my mind.
Well, maybe we'll start with the second question. What exactly do we look for in SETI, and how do we know that other technologies might do the same thing that we do? All technology, electromagnetic technology on Earth, has a particular feature that is distinguishable from natural sources of electromagnetic radiation. And that is that technology has a high degree of coherence. It can compress electromagnetic energy into very narrow regions of frequency space or wavelength, like a laser that's only one color, or very narrow regions in time, like a radar pulse that might be sent out by an aircraft radar. And this is something that, in general, the natural world doesn't do. And this is basically the property of electromagnetic radiation that we look for when we do searches for extraterrestrial intelligence. Now, one might ask, well, how do we know that other technology might do that or might not do that? And the truth is that we don't know. We know of only one example of life, let alone intelligent life, anywhere in the universe. And so we're forced to use our own experience with technology as a proxy. Now, of course, we do try to think outside the box as much as possible and imagine what our technology might look like 50 years or 100 years or perhaps several thousand years into the future. And we factor those things into our searches, especially when we're looking for very large structures around other stars, like Dyson spheres, large structures that might collect radiation for solar power. But indeed, at the end of the day, we have to use our own technology as a model for what other civilizations might do. Now, I'll add that although most of our electromagnetic technology is used for communication or for ranging in the case of radar, our searches are agnostic to the motivation of the other civilization or the other technology. So we could just as easily detect a laser communication system like we have here on Earth as we could a giant interplanetary laser light show that some civilization produced purely for their own amusement. We don't have to worry about the motivations of why the civilization produced the signal.
And that sort of ties back to the first question that I asked, because in getting ready for this episode, I read something about the specificity, the relatively low power that and that an alien energy source would have to produce for you to be able to detect. And it sort of boggled my mind. So can you talk a little bit about the technology you're using today and how specific it can be?
Sure. Well, the most important thing that's changed in SETI today versus SETI in 1960, when Frank carried out his very first experiment, is the microprocessor revolution, the availability of ubiquitous and very inexpensive computing. And particularly when we're searching the radio part of the spectrum, the amount of the spectrum that we can search, and thereby our sensitivity, or the speed of our search, is directly hinged on the speed of our computers. So as computers get faster and faster, we can search more and more of the electromagnetic spectrum. And our searches today literally can search billions of times more spectrum than Frank's searches were able to do back in 1960s. And that's all because computers are much, much faster. There are also qualitative changes in how we do SETI. Of course, in 1960, the laser was just a glint in Charlie Towne's eye when he was inventing that technology right at that time. But now, of course, lasers are ubiquitous within our own technology. We use them for all sorts of purposes. And we can do a similar calculation with lasers as we do with radio signals, and we can calculate what sensitivity would be required for us to detect a laser signal coming from a distant extrasolar planet. And when you do those calculations, you can determine that, in fact, lasers of reasonable power, even hundreds of watts or kilowatts, could be detected under the right circumstances with our experiments.
So before we get deeper into the science, I want to step back for a second, and there are two things that I'm interested. You mentioned the size of well, you didn't mention the size of the universe. Given the size of the universe and the fact that we know that life on this planet is the only life, certainly advanced life, don't you think the odds are, given the size of the universe, that there has to be some intelligent life out there? I mean, what's your personal belief on that? Again, stepping back from the size.
Yeah, it's a fantastic question. As you said, there's a lot of real estate out there. We've learned just in the last decade that essentially every star in the Milky Way galaxy has a planetary system, and some 10 or 20% are what we call Earth-like planets, planets that are about the same size and temperature as the Earth. And there are hundreds of billions, perhaps even a couple of trillion galaxies in the universe. So there's an awful lot of places out there where life can emerge. But we also know that we don't see any other life for the moment anywhere else in our solar system. We don't see obvious signs of extant or even extinct life on Mars or other bodies in our solar system. So, and moreover, we're not able to create life in the laboratory. We can take prebiotic chemicals and we can stick them in a test tube, and we can expose it to all sorts of thermocycling and electricity, things that mimic the very early Earth environment, and we haven't been able to create life. So we know that there's some low probability that life will emerge given the necessary conditions, but we don't know how low that probability is. There could be 100 billion opportunities for life to emerge somewhere just in the Milky Way galaxy on these planets. But if the odds are 10 to the minus 15 or 10 to the minus 20, then you might end up with life being a fairly uncommon occurrence. We simply do not know the answer to this question. But at the end of the day, this is, of course, why we search for life, because this is the way that we will answer this.
The other question I had, I first became familiar or more familiar with your work reading a recent issue of Science. And it got me thinking. First thing I thought was, well, we've got to get Andrew on the show. So again, thank you for coming on. But the second thing it got me thinking was there has been there has been an interest in this going back to centuries, even millennia. You touched on that earlier. In the more modern era, we've got H.G. Wells in literature and a whole body of science fiction. We've got Spielberg's movies. What is the long human fascination with what is out there? Is it life as we might recognize it?
You're maybe asking the wrong person, kind of preaching to the choir in some sense. My question always is why aren't more scientists working in this area? Of course, as some of the recent reporting on this topic has indicated, the search for extraterrestrial intelligence has not always been fully embraced by the mainstream scientific community. From my perspective, the presence of life in the universe is the most interesting part of the universe. It's the most paradoxical and intriguing and awe-inspiring thing about the universe, and it might even end up being the defining property of the universe. We don't know the answer to that. As I said, I think the search for life, and especially intelligent life, is an incredibly natural question to explore as a human or as a scientist. So I guess its obviousness in some sense maybe hides the ultimate reason why it does capture the imagination so readily.
So, Andrew, it seems like in the last couple of years, I've heard things in the news about, I think they're called fast repeaters, but some signals from space that seem to not be of terrestrial origin and defy explanation at this point. Are there signals that you've seen that are still open questions about what they are?
Yeah, so these are called fast radio bursts, very brief, impulsive sources of radiation that occasionally repeat. And we absolutely know that they're extraterrestrial. We even know that they're extragalactic. They come from outside the Milky Way galaxy. There are some theories as to what might cause these. Most of them have to do with very compact, dense stellar remnants called neutron stars. And in those very extreme environments around neutron stars, you might be able to produce these radio flashes. The history of astronomy is the history of unexpected discovery, and seeing things that we don't quite understand, and then coming up with a theoretical model for what the source of that signal might be, and then testing that with additional observations or other predictions. And indeed, this is happening all the time in astronomy. And when fast radio bursts were first discovered in 2007, the question of whether or not it could be some evidence of extraterrestrial intelligence was indeed on everybody's mind. I think today we're fairly convinced that these are naturally occurring, at least most of them are naturally occurring phenomena. But again, the jury is still out. We don't know definitively what causes fast radio bursts. With regard to other kinds of signals, there's nothing burning in my email right as we speak that we need to be following up on. But we're constantly searching our archival data. We're constantly adding new capabilities to new telescopes, and things are popping up all the time. Unfortunately, within a matter of minutes, we're able to determine that in most cases these are caused by terrestrial signals, terrestrial radio frequency interference.
So you are the principal investigator for the Breakthrough Listen program, which I would argue is a revolutionary effort. Tell us about that, how it started, and what it was doing.
Sure. Breakthrough Listen is a 10-year, $100 million initiative to conduct the most comprehensive, sensitive, and intensive search for extraterrestrial intelligence in history. It was launched in 2015 by an internet investor from Silicon Valley named Yuri Milner at the Royal Society in London. And at that announcement, Yuri was joined by Stephen Hawking, Frank Drake, Martin Rees, and Anne Druyan, the widow of the late Carl Sagan, to launch this initiative. That program is headquartered at UC Berkeley. And basically, the program is kind of centered around the idea that we want to marshal all of the world's resources, from astronomical resources and telescopes to machine learning and data analysis expertise, to really make a concerted effort to try to answer this question in the most significant way that it's ever been attempted. And that's precisely what we've been doing for the last 5 years. And what we'll certainly continue to do for the remaining nominal 5 years of the program.
Milner is an Israeli-Russian venture capitalist entrepreneur. He lives not too far from you. What got him interested in this? Do you know if you could speak for him, or I'm sure he's told you, why did he become other people like Paul Allen from the software and Silicon Valley area have had the same interest? What is his interest here?
Well, I certainly can't speak for him, but I can say that everybody that I know in this field that is interested in it, I think shares the same sort of spark of wonder that many of us have when we look up at the night sky, in wanting to know whether or not there's someone or something else out there that we might one day be able to learn from, perhaps even to communicate with. And I think absolutely, at least from my interactions with Yuri, he shares that same deep and fundamental passion about just wanting to know what's out there in the universe.
So in that interview, Science Magazine that I mentioned, or in that story, he was interviewed and he had a quote. I'm going to read it here because I just thought it was wonderful. Milner said, quote, "It's one of the most existential questions in our universe. Just knowing we are not alone is something that can bring us together here on Earth." All right, that's profound, particularly now in 2020, in the middle of a pandemic and political polarization. Do you share that sentiment too?
Absolutely, I think it's a beautiful sentiment, and certainly something that we think about in our search by imagining that in fact there could be other intelligent life on other planets far removed from our own Earth. That it naturally causes us to think more about our kinship with other human beings that oftentimes can get lost when we only imagine our entire universe existing on the surface of this small blue marble in one corner of the Milky Way.
Andrew, you're a relatively young scholar. You have got a bachelor's and a master's degree and a PhD. What drew you to the field of astrophysics?
Well, I've of course always been interested in space, and like most, I think, yeah, young kids, I had a fascination with space and dinosaurs. And when I found myself looking at majors to study in college, astrophysics certainly stood out to me. I didn't ever intend on becoming a quote unquote professional astronomer or astrophysicist. It was just something that I found very interesting. And when I discovered that there was a part of astrophysics that was centered around the search for intelligent life in the universe, it was really the proverbial light bulb. There was never going to be anything else in astrophysics that I would ever really do or feel nearly as passionate about as this topic. And of course, when I was an undergraduate and even a graduate student at Berkeley, the idea that one could actually make a professional career out of this field was very uncertain. But of course, that has changed quite a lot with Breakthrough Listen.
So you're doing the hard science, and all the people involved in that program are doing the hard science as well, and it's great work. There must be times, however, during this when you think to yourself in an idle moment or falling asleep or whatever, you must wonder if there is extraterrestrial intelligent life, what do they look like? What do they think? Why would they want to contact people on Earth if in fact they might want to contact people on Earth? So that's a lot of questions, but what's your imagination? Where do you go with that?
Well, this is an incredibly profound question. We could spend, many hours, weeks, years talking about this topic. Indeed, sometimes I do think about that. I think about what the motivations of a very advanced civilization might be. I think about maybe how if they attained a very high level of technological sophistication, how they did that, how they learned to work with one another, how they learned to overcome some of the challenges that surely they experienced in their technological evolution. I think it's important with regard to motivations. I think it's important to remember that our searches actually don't require that another civilization is intentionally trying to signal
Right.
us. It might be that we just detect some inadvertent evidence of their existence. But it really does boggle the mind to imagine a civilization that might be millions or even billions of years more advanced than our own, and what sorts of things they might have learned and what capabilities they might have attained.
So we've got a little bit more than a minute left here, and I don't remember if it was Stephen Hawking, but I want to say Stephen Hawking warned about the potential for contact with an extraterrestrial intelligence, that if they were so technologically superior to theirs and they were aggressive, that would be a bad day for planet Earth. Is it silly to take our thinking that far? Or is there some reason for us to be at least a little bit respectful of the cosmos?
Well, there are two possibilities, as Arthur C. Clarke said: either we're alone or we're not, and they're both equally terrifying. Indeed, if we don't detect anything, it tells us that the lifetime of civilizations is very short, which means we need to be very, very careful with our own civilization. But if we do detect another civilization, it tells us that the lifetime is long. And that means that there are many other intelligent civilizations far more advanced than we are. And we certainly don't have any reason to believe that technological progression is somehow attached to altruism. That is, that very advanced civilizations would necessarily be more friendly. That said, I think I'll share something that Andrew shared with us when we were talking about this in the very early days of Breakthrough Listen, and that there are really kind of two ways that you can approach the universe. You can approach it by projecting all of the worst parts of humanity, all of the fear and the danger and the conflict, and project those out to other civilizations that we might encounter. Or you can project the most beautiful parts of humanity, the art and the love and the camaraderie that also is a part of the human condition. And I think for my part, I try not to sort of go too far down either one of those directions, and kind of try to imagine that if there's some negativity out there, well, there's probably some positivity as well, and some beautiful things we have to discover.
And that's a great place for us to leave it today. Andrew Siemion, thank you so much for being with us. That's all the time we have this week for Story in the Public Square. But if you want to know more, you can visit us at pellcenter.org, where you can always catch up on previous episodes. For G. Wayne Miller, I'm Jim Ludus, asking you to join us again next time for more Story in the Public Square.